sometimes we do not want to know the exact root of the quadratic equation. We want to know the nature of the root of the quadratic equation. Let me give an example. Suppose you have a quadratic equation x squared plus x minus 6 equal to 0. Whenever I'm saying quadratic equation, I'm referring to solving equation, not the Cartesian equation. So if we solve it, we can use the middle term break rule, which is x squared plus thrice x minus twice x minus 6 equals to 0. And we can take x common and it would be x plus 3 minus 2x plus 3 equal to 0, and the factors would be x plus 3, x minus 2 equal to 0, and we would have two roots. One would be x equals to minus 3, or the other one would be x equals to 2. So we know what the exact roots are. Now the same quadratic equation can be solved using the quadratic formula, and this is what I'll be referring to here. So if we use the quadratic formula, we can directly find the root x equals to minus b is the coefficient of x, which is 1, plus minus root over, and this is very important, this root over concept. So b squared, so coefficient of x is plus 1 squared minus 4. A is the coefficient of x squared, so it is 1, and c is the constant without any x, which is minus 6, divided by twice a is 1. So this would be minus 1 plus minus root over. So 1 square is 1. Minus 4 into minus 6 is 24. So 24 plus 1 is 25 divided by 2. So this would be minus 1 plus minus root over 25 is 5 divided by 2. So now plus minus means two things written together. So it means minus 1 plus 5 by 2, which is equals to 5 minus 1 is 4. 4 by 2 is 2. And another thing is minus 1 minus 5 by 2, which is minus 6 by 2 minus 3. So we get the two roots all over again, minus 3 and 2. So we know the exact roots. One of the root is minus 3 and the other one is 2. So x equals to minus 3 or x equals to 2. For the next example, I'm going to use the quadratic formula. So let's use another question. So x squared plus twice x plus 1 equals to 0. So we have another equation, and let me solve this again directly using the quadratic formula. It would be, the root would be x equals to minus b, the coefficient of x is plus 2, so it would be minus 2, plus or minus written together to save space. So b squared is plus 2 whole squared minus 4, a is 1 and c is plus 1 divided by twice a is 1. So we get minus 2 plus minus, now root over, take a look here, 4, 2 squared is 4, minus 4, so that is 0 divided by 2. Now if it is 0, one value is going to be minus 2 plus 0 by 2, which is 1, which is minus 1, because it doesn't really matter if you add something with 0, and the other value is minus 2 minus 0 by 2, which is also minus 1. You see, since it doesn't matter whether we add a number with 0 or subtract a number with 0, the root, we are getting two roots, but the roots are not different. They're the same roots, but we are getting two roots. So for the first example, we are getting two different roots. I'll call this two roots. Here we are getting one unique root. I'll call this one root. Now let me show you a third example. In the third example, look how we cannot find any root. So this one is x squared plus x plus 5 equals to 0. So when we solve this directly, we get x as the root equals to minus b. So coefficient of x is b, so minus 1 plus minus root over b squared, which is 1 squared minus 4, a is 1 and c is plus 5 divided by twice a is the coefficient of x squared, which is 1. This turns out to be minus 1 plus minus square root of 1 square is 1 minus 4 5s are 20. So this turns out to be negative minus 19 divided by 2. Now here we have to calculate what is minus 19. If we take out our calculator, we will see that square root of minus 19 is math error. It means it cannot be found. We cannot calculate the negative square root. Actually, the problem is not with minus 19. Doesn't matter what it is. The problem is with minus 1, because we can simply write it as square root of 19 into minus 1. And we can bring the square root of 19. We can find the square root of 19, but we will not be able to find the square root of minus 1. So the problem is not with square root of any negative number. The problem is with minus 1 square root. For example, if you have square root of minus 16, you can easily write it as 16 into minus 1. So square root of 16 is 4. We don't know what the square root of minus 1 is. If you write square root of minus 25, similarly we can write square root of 25 multiplied by square root of minus 1. Square root of 25 is 5, and square root of minus 1 is the problem. We don't know what to do with it. Now if you have square root of minus 36, so same thing, this would be square root of 36 times square root of minus 1, which is 6 square root of minus 1. We don't know what that is. So the problem is basically with square root of minus 1. If you do square root of minus 1, we get a math error. So this thing, square root of minus 1, is a mathematical problem. And we call this we have many names to call this. We can call this complex number. That is the most common name to call it. Complex number, and it is often referred to as I. So square root of minus 1 is I. So this value would be 4i, this would be 5i small letter I, and this would be 6 small letter I. And this is a complex number, so we call this a complex number. Square root of number 1 is also called an unreal number, or it can also be called an imaginary number. Imaginary number. So complex number, unreal number, imaginary number all refers to square root of a negative number. It doesn't matter what the entire number is. We can also always bring it outside the square root, like 16 becomes 4. But the problem is always with square root of negative 1. Now, why do we have this problem? What is the concept of complex number, and why do we have this? Why do we have to deal with this? Now, think of, where does square root come from? What would be the previous line? Think of that. Suppose we have x equals to square root of minus 1. That means the previous line must have been x squared equals to minus 1. Now x squared means x multiplied with itself. So x into x. So it means if you multiply x with itself, it would be minus 1. Now this is not possible. The reason it is not possible because if you multiply x with itself, it means if x is positive, you're multiplying positive with positive, which is a positive number. But if x is negative, you're multiplying negative with negative, which is also a positive number. It is no way possible to multiply positive with positive or negative with negative and get a negative number. So it is not possible. For this reason, we call this an unreal number. For that reason, so square root of minus 1 is either unreal, or we can call it complex number, or we can call it imaginary number, and we often give the symbol I. So the symbol I refers to square root of minus 1 or the imaginary number. So whenever we have a square root, we have to be very careful whether we have some value which is unreal or complex or imaginary, same thing. So let's take a look over here. When we solve this particular question, we found out that the root cannot be found, meaning the value of x cannot be found because inside the square root it's a negative number. So we'll say that the roots are unreal. One thing is very important. Whenever I am referring to the root of the equation, I am referring to the unknown value of x. This symbol over here, this is known as the square root or the radical. So it is important to remember whenever I'm referring to the root of the equation, I'm not talking about the square root, I'm talking about the unknown values of x. So this we say since we find the value over here, so we can say that this has real roots and they're different. So they're real and different roots. The second example, we have real root all right, but they're real and equal roots. The roots are equal. Another word for equal is same root or coincidental roots. Another word for different is distinct roots or separate roots. But over here, we couldn't find any root at all because of negative. There is a negative number inside the square root. So here we say that the roots are not real or unreal roots. We can also call them complex roots or imaginary roots, same thing. This is what we mean by the nature of the quadratic equation, the root of the quadratic equation. There are first of all two different types. First, so when we are talking about the nature of roots of the quadratic equation, first of all, we can break them down into two different roots. It could be unreal, meaning imaginary or complex, or it could be real, meaning everything else. If it is real, it could be two different roots, like real and different. It could be different roots, or it could be equal roots. So we have basically three situations or two main categories. It could be real and different, it could be real and equal, or it could be unreal. So now if you write down a quadratic equation, so ax squared plus bx plus c equal to 0. So this is a quadratic equation, and if you write down the root of the quadratic equation, so minus b plus minus root over b squared minus 4ac divided by twice a. Now you're not interested what the actual value of the root would be. All you want to know whether the root would be unreal or they would be real, meaning real and different or real and equal. So that's the nature of the root. So since everything depends on what is inside the square root, so here the determining factor would be this thing, whatever is inside the square root. So it means if this thing b squared minus 4ac is negative, written as less than 0 in math, negative means less than 0. This is how we write negative numbers. So if this is negative, that means inside the square root there would be something negative, and we know it is not possible to find out the value of square root of a negative number, so it would be unreal root. So if b squared minus 4ac is negative, we write it as less than 0, then it would be roots would be unreal. So we know the nature of the root. If on the other hand b squared minus 4ac is positive, meaning not negative or 0, so the roots would be real. So we have basically two situations. Either the roots would be negative or it would not be negative. Not to be negative means two situations. We can again break this down into two situations. So it could be b squared minus 4ac positive, meaning greater than 0. So that means it would be real, definitely real, and it would be different. There would be two different roots. If b squared minus 4ac is equal to 0, then it would be real and the roots would be equal to each other, that we have seen before. So for knowing the nature of the root, the determining factor is not what the other values are, but what is inside the square root, because we know everything depends on the negative, whether inside the square root is negative or positive or 0. So in order to find the nature of the root, we don't need to actually solve it. All we need to know is what are the values of this. This is known as the discriminant. This is known as the discriminant, b squared minus 4ac, because on the discriminant depends on the nature of the root. We can also look at it as visually as the parabola. Remember, if y equals to x squared plus bx plus c, since we have two unknown variables, both x and y, this would be a picture. This is called the Cartesian equation. The picture would be a parabola. Now, if you think of a quadratic equation which we solve as x squared plus bx plus c equal to 0, so this is the solving equation and this is the picture equation of the Cartesian equation. So when we say that b squared minus 4ac is greater than 0, b squared minus 4ac is equal to 0, and b squared minus 4ac is less than 0, negative, we say this is unreal root. So unreal root. So visually it means it does not cut the x-axis. That's what it means, unreal root. The parabola does not cut the x-axis. B squared minus 4ac greater than 0, meaning real and different roots. That means it cuts the x-axis at two different places. B squared minus 4ac equal to 0. That means it cuts the x-axis at exactly one place. That's what it means visually.